I'm very excited to be here with all of you. Thanks for coming to OpenXdata. This is the, I think, second time we've run OpenXdata, and it's really brought together an incredible community of people that are contributors, builders, leaders in open source across a wide, diverse range of open source projects. So excited to keep the sparks flying, hopefully, with this kind of a talk here about the spark you knew is dead. I want to talk about a quiet Lakehouse revolution that I see happening behind the scenes, and I hope that everyone can tune into it so that they can stay ahead of where things are moving and how things are changing. A little bit of introduction for me. I am Kyle. I run product and our technical field team at Onehouse. I've been with the company since we started the company. And yeah, I've been building data lakes and data products for about 13 years. And so I've been a large user of Apache Spark. I also, while I was at Microsoft, I helped partner with Databricks, and we created and launched the first version of Azure Databricks. So it's quite a fun time right before I decided to jump ship and build the new future of the Lakehouse with Vinod, who you heard at the keynote here at Onehouse. So today, yes, I'm trying to throw a little bit of sparks, a little bit of provocative statements up front. But before we get into that, if I'm going to tell you about how something you knew about before is potentially dead, let's talk about the history of it. Let's look at the original rise of Apache Spark. This is an article that I found that's dated 2014. The internet's a beautiful place. We are now collecting history. And so this, for the speed in which data moves, this is a historic relic at this time, at this stage. This should be in a museum somewhere, 2014. You can see even the Databricks logo, what maybe their original logo looked like back in 2014. But this article talks about how Spark has surpassed Hadoop in popularity. And you can see the little chart that they drew on this article. And so this is a very exciting time for the data community. At this time, I was actually at Microsoft. I was building a hundreds of terabytes, even petabyte scale data platform for Microsoft Office products. They've just launched O365, the online web applications, those kind of things. We had incredible amounts of data and telemetry that we were dealing with and wrangling with. I wasn't using Spark yet. I was still on some Hadoop and other internal tools, but I was watching this firsthand, this rise of Hadoop in 2014, or of Spark in 2014, and as it started to grow into the incredible community that it now is today. And how is that relevant still holding up today? This is a poll and research that was done in 2025, so it's very recent here. And this was an analysis of job postings for data engineers, and it started to tally up the required skills that were listed for all job postings across data engineers that they analyzed. The number one tool that was listed as required for jobs in 2025 for data engineers was Apache Spark. You can see that listed there on top, followed by Snowflake, Kafka, Hadoop, Databricks, other things that you're familiar with. But Apache Spark is something that is in hot demand even still today in 2025, 2026. Now, another research article, and you can message me for the links to all of this research, was analyzing, like, if you're using Spark, what's the flavor of Spark, or how are you deploying Spark? How are you using it today? Of course, majority of folks were found using Databricks, which they're original creators of Apache Spark, and they have an incredible product as well. Close behind that is actually folks running is Apache Spark in open source, leveraging Kubernetes and running this on their own, leveraging the open source version, handling deployments and management, configurations, tuning, and they're happy to build their platforms this way. Now, as we look at the relevance and the growth and where Spark is today, let's talk about two things that are changing. Let's look at what I see as maybe the largest change in the last close to decade, about 8-year span here. And then I want to tell you what I think is next for the next probably just about 2 years until the next wave gets finalized. But here, 2016 to 2024, one thing that was really impactful, Spark's not idempotent. And if you like this funny meme on the side, this can happen to your data in real life while using Spark. You can have partial writes, the job can fail midway. It has eventual consistency. The compute by nature is distributed. And so there's multiple nodes that are doing tasks across, and it doesn't have like an all or nothing transactional definition. for how it's writing data into your file system. And so because of that, there were some interesting technologies born in this era, 2016 to 2024. The first of those was Apache Hudi, who our founder and CEO of our company, also the one who gave the keynote today earlier. He's the original creator of this technology. He created the world's first Lakehouse when he was an engineer at Uber, and Uber was going through their massive growth period for data and their business as a whole. And so Apache Hudi Iceberg was also created in about 2019 from Netflix. And Apache Hudi Iceberg, Delta Lake, I didn't list here, but they're all three very similar in nature. Each of them has a specialization in certain ways where Hudi, for example, is amazing and great for fast, near real time, fast moving data. That's something that you just saw in the last talk from Andre at Conductor after they had evaluated that way. But all these projects are great, and there's something common across them that was solved in the last kind of era, 2016 to 2024, that was really important, that idempotency. We were able to bring ACID transactional guarantees to the write operations that happened with Apache Spark. So now we've got a compute framework that is massive and distributed, that is able to handle large scale of data, and it can process it quite fast. And now it can also process it in a safe ACID transactional way. That's one thing that the formats opened up. Other things that it opened up, of course, you've got additional metadata layers on there that can improve the performance of how you access and continue writing and mutating that data. It allows you to then express things like schema evolution or different ways that you can define the partitions of that data as it's being written. So these Lakehouse table formats really cemented that position for Apache Spark and made the Lakehouse style architectural pattern become like the first and foremost thing. I like the poll that you had up there, Demetrios. It did show interesting results that many people were Lakehouse first data platforms in their companies. There was a large portion, if I remember, it was 20 something percent of warehouse only. And then the largest, it was 38% or so. I could be remembering wrong, go check the poll, were hybrid, some warehouse, some Lakehouse. And so pretty much everyone's got a data lake today. And if you have a data lake, you are very highly likely to use a technology like Apache Spark. But let's talk about what's changing right now. What's changing out from underneath us? It started to change just and maybe in about last year. And I predict that this would take only about till 2027 to kind of fully operationalize, get through the community and have some new things that are really solid and adopted and have many success stories from others. So the thing that has been changing recently, I've got this sad picture of this cup of coffee here, and you might reference and follow me here with the link of coffee to Java, Java to JVM, JVM to Apache Spark. Apache Spark is all based off of the compute that's being processed and managed inside of these JVMs, Java virtual environments. And now inside of their hardware has been evolving much faster than the programming language has been evolving. And so hardware, we're talking like when you're in the cloud on EC2 instances or and you're picking different types, that physical hardware has evolved faster. It's created new even instruction sets and operations that are available at the lowest layers of the hardware to accelerate different types of operations. For example, there's a operation called a SIMD operation, and it allows you to process multiple values at the same time and parallelize this. Something that Java, when your process is in a JVM, it's not able to take advantage of. And so something that's been quietly changing for the last year or so is how Apache Spark, it's maintaining its position as the incredible compute orchestrator. And the really hardened and battle-tested APIs that it delivers for allowing people to write complex ETL jobs, even generative AI applications, machine learning. It is a well battle-tested, well-oiled machine for being compute orchestration and how it federates that plan out into multiple distributed nodes for execution. But the core of the engine, if you were to say, is being now created into a portable layer. And so you see a list of different types of companies that are working on initiatives in this world. Databricks was one of the first to get in there with what they call the Photon engine. And so they did a rewrite in C++ of some of the execution parts and how they execute Spark jobs. Onehouse, we're a new player here in the market. We have created an engine that we call Quanton. And Quanton, in a similar nature, it allows you to have vectorized or native execution for your Spark jobs. Similarly, I won't read them all, but NVIDIA, Intel, Meta, all these companies are building out native execution engines that can run as a component inside of or attached to or as part of Apache Spark. So what the beauty of what happens here, like I'm most familiar with Quanton, of course, because this is what we've built and launched what we're running here inside Onehouse. But this diagram, this kind of sandwich, if you will, on the right-hand side, you keep the Apache Spark APIs the same, 100% compatibility, no tweaks, no changes. The code that you've written to write your Spark job stays the same, no impact. On the bottom of the sandwich, you have the open table formats, leveraging Apache Hudi, Apache Iceberg, Delta Lake. Don't make any changes for how you're accessing that data inside there, but change in the middle, how the execution runtime operates, and what I would call the storage engine. The storage engine is then how you talk to and communicate with and leverage advanced statistics and metadata around the open table formats. So these are the two components that, at least here with the Quanton, we've been working very hard and diligently to accelerate so that your Apache Spark jobs can go much faster. To give you a view into this, we've done countless benchmarks. You can scan the QR code on the bottom right. This is only one TPCDS benchmark, but we've ran TPCDI, TPCXBB, Lake Loader, so many different benchmarks that we've documented in depth, and you can scan that QR code for a blog that goes into the details. But you can see us side by side with Databricks with their Photon engine, Snowflake, and EMR, where they've added some compute accelerations, adopting some open source technologies. You can see where Quanton from Onehouse stacks in a price performance competition with these types of engines. So Quantum's faster because some of these things I mentioned, like SIMD, vectorized execution, these are techniques that might be a little bit similar to open source projects. You might be following things like Gluten, Velox, Data Fusion. We also add in there aggressive query plan optimizations, high throughput data scanning. Our Spark runtime is now very aware of the storage optimizations that need to be done. Because we come from a historical background of being the pioneers of open table formats and creating these, we know very well how to deeply leverage Hudi, Iceberg, and Delta Lake to accelerate your jobs. So we've created ways to amortize execution costs. We exploit repetitive patterns. There's so many ways. Scan the link on the chat window to make sure you can read about these details in depth. I'm trying to watch the clock as well. Demetrius, drop me a note in the speaker chat on what time I should wrap my talk. I want to time it right here too. Now, looking at one layer deeper, okay, how would you use something like Quanton? Of course, I'm not going to cover how you use all the others, but I'll give you an example here. And actually, this is something that I think is unique and some exciting things that I want to announce and share with you today. So from a Onehouse perspective, we have two main ways that you can adopt or try to use the Quanton accelerated Apache Spark engine. We have a BYOC model. What I call this is bring your own cloud, where we deploy a serverless data plane inside of your VPC. So you're on AWS, you're on Azure, you're on Google Cloud, and thanks, Steve. And you are now deploying inside of your own VPC a data plane that has a serverless distributed compute inside there. Now, the other model that we have is what we call our Quanton Kubernetes operator. And this can be cloud or on-prem or in any hybrid environment. Anywhere you have running Kubernetes, where you have a Kubernetes, you actually can, in a very lightweight way, deploy our what we call Quanton Kubernetes operator. So let me accelerate. Oh, 12:05. Good. Okay, we're solid. All right. So the steps to get started are very easy. You can download a YAML configuration file that we give you. You run a Helm upgrade, and you reference that configuration file, and then you just execute your Spark jobs. No changes to the code. This kubectl apply, and you have your CRD for your Spark application. You just run the same job, but now you've done a Helm upgrade and you've installed the operator inside of your K8 cluster. That's how you can take advantage of and use all of the accelerations from Quanton from Onehouse. Now, one thing I want to call out, there is a live workshop happening later today around about 3:35 p.m. with Sagar from our team here, who's going to give you a hands-on workshop. You can go step by step with him, and you can try this out later today if you want to go to that session. So yeah, now I want to talk just briefly about the platform, and then I'll show you a very fast speed demo. So Onehouse, I've talked about this engine and open table formats a lot. But on top of these building blocks, Onehouse as a platform offers fully managed ingestion, from ingesting your streams, your files, or your databases. Stream all that data into open table formats in your cloud storage buckets. And then we also have a full Spark and SQL ETL platform where you can take your Spark jobs, no code changes to what you might have been running with EMR or Databricks or anything else. Now you can run those jobs on Onehouse and monitor and accelerate those jobs. We also just recently launched what we call Lakebase. It's an analytics and AI serving layer, which allows you to, it plugs in really well to Vinod's keynote, how he was talking about where there's differences in how now agentic workloads are coming to talk to your data. And so we have some very interesting support there. I won't go through all these details, but let me show you some speed run of the platform live. The first thing that I have loaded up in my Onehouse console is actually a flow, what we call a flow. This is the fully managed ingestion platform. This is ingesting data from, if I go to setup here, this is ingesting data from Kafka, and it's a Confluent Kafka connector. And I can see how much data has been ingested in near real time. I can see how much data was pending to write as it's building up in the queue. And I can see how fast the sync duration was on average for these commits and for the operations. So it's very easy to come in and set these things up. You see I have multiple that are running. I can say, let's add a new flow. This is as you would expect. I can add some sources, put in some details about configurations, choose, for example, tables or topics that I want to ingest, and then I choose a destination and a catalog to synchronize to. All of this runs on a cluster of your choice. So the next thing I'll show you is how you can manage virtual clusters. I come here to my clusters tab. I have a whole bunch of them in my little demo environment, some that are running. If I want to create one, I say, let's add a new cluster. I can now choose a type. We're able to run SQL workloads, Spark jobs, even open source engines if you want to deploy a different style of technology. You can deploy one with a Jupyter notebook fully loaded, ready to go, and even Lakebase itself. Inside here, you choose the scaling ranges, which catalog you're connected to by default. You hit go, your clusters are up and running. So let me show you perhaps one of these clusters. It's a Spark cluster. And I can monitor the usage of the cluster. I can see what jobs were submitted to this cluster. I can go into these jobs and see individual runs. And inside of the runs, I also can get access to the Spark logs. I can open the Spark UI, all of the things you might expect from a well-oiled Spark product machine. In addition, we also have, as your data is created, table services that run in the background, compaction, clustering, cleaning. Andre had mentioned some of those details about managing a data platform, and all of this runs for you as you have it. So that's just a little bit of a speed run here for Onehouse. The other thing that I want to show you is something brand new that we've launched today. I thought I had a slide. Yeah, I must have skipped this slide. The thing that we're announcing today is a new free tier for Onehouse. This is a completely new freemium model, no sales involved, no credit cards required. Go to quantum.dev or scan this QR code. And there is a website here that I actually vibe coded this website. No code was ever written. It was all just prompts and Claude. And tell me if you like the website or not. It's brand new. We're launching today. But you can come to there, create an account, and there's documentation and everything for how to get started in a very easy way. If you want to upgrade, you can talk to us later. But hopefully, this gives you a really fast way, even from the start of this conference, to now get your hands on and try it. We'll be doing a live workshop on this later near 3:30, 3:40. Come to that as well. So with that, I just want to wrap up the session, and I should be watching the chat for questions. So start adding those in questions from in the chat or the QA window, and I'll be to those soon. And here, that's that QR code again to get access to quantum.dev. Or we also have a Slack community. If you've been loving the chat's on fire in here, Demetrius. For everyone that's having a good time talking on chat, if you want to continue conversations, we've got a Slack community for Onehouse that you can scan the QR code on the right. We'd be happy to chat. It's a new evolving community. So come talk about what you want to talk about, and we'll evolve the channels. Let's adapt. Let's make it something that the community can use for open source data.
Yes, sir. So I've got some questions while people are doing the cat meme and frantically typing away their questions.
All right. All right.
Recently, I actually did a podcast with some folks from Uber, and they were saying that they had all these resources to GPUs, right?
Mm.
Or they had all these GPU resources, I think better said. But the bottleneck wasn't the GPU, it was getting the data to the GPU. Because the way that
Oh, yes.
he explained it to me was GPUs are very hungry and they're just like,
Yes.
they're always, they eat the data really quickly. And so
Yes.
you have to think about all of the different stages before it gets to the GPU and recognize where the bottlenecks are a little more
Yes.
upstream. What you just presented, is that um, is that going to help in that regard?
Sure.
Like,
There's something that's similar in nature to what you're describing. I actually studied electrical and computer engineering, so I really love that analogy of the GPUs being hungry and how like the CPU architecture can then come and because oftentimes, and that's the bottleneck, is how you give data fast enough to the GPU. Because the GPU is revved up, ready to go, and it's got a great architecture for parallel processing, but the speed at which you send it to there. So what I've shared today with Quanton and the accelerations that we've driven inside here, it isn't about how to spread data or serve data across things like CPUs and GPUs. Something I would recommend for folks that are interested in that topic to read more about is actually Ray. There is a presenter from Anyscale on the agenda list. Look, or Control F on OpenXdata.ai for Anyscale or Ray, and you'll see a great session. Go to that session. It talks a lot about how you can accelerate data and get it faster to GPUs as well. What I'm talking about inside here, these types of accelerations are a little bit closer to just the CPU architecture and how you can plug into different instruction sets inside of the CPU when you go from writing and having processes run in a JVM to now closer to hardware production, things like C++, Rust, these other types of programming languages that let you tap in, wire in a little bit deeper. That's what I'm talking about here.
nice, nice. All right. Question from Loic. I probably butchered that name, and I'm sorry if I did. Okay, since Java is the core technology for most of the scalable services we are using, in your opinion, what is the likelihood that the JIT compilers are going to leverage better the advancements made in the past couple of years in CPU and GPU?
Yeah, I think they have to. There's if if the community cannot make the compilers leverage these advancements faster, like it's not sustainable for that community or technology to continue being dominant and being the first and foremost choice. Like Java's de facto standard basically for data and data processing today because of many reasons. Hadoop or Spark or some of these things could be a part of it, but I am not plugged in deeply into the communities to watch that progress or see what the discussions are. I haven't followed it myself personally, but it's got to happen. The JIT compilers have got to be able to leverage this stuff better. Hopefully it happens. So it'll be the best for all of us.
All right. We are going to ask one more and then we got to keep it moving.
Mhm.
It's about security.
Okay.
How do you plan to implement data security with the complexities of the platform?
Yeah, awesome. So data security, this is actually something very interesting. There's so many layers when it comes to data security. I'm going to zoom in and maybe answer the question from a perspective of, I saw in your song as you were singing, you talked about RBAC. RBAC controls and data policies that are written for access controls. One thing that I see really a problem across the data world today is your permissions are created and authored. These policies are generated in different systems. You're using AWS Lake Formation, perhaps, but you also are using Databricks and they want those policies written in Unity Catalog. You're also using Snowflake and they want the policies natively written in that platform. Across the board, every single system, you have to re-author your policies. One thing that's very exciting, we announced maybe it was last month, alongside with Microsoft, is actually what we call OneSync, and it has a data policy translation mechanism that allows you to take all of the RBAC policies that you've written in, for example, Lake Formation. You can extract, translate to them to Unity Catalog and commit them to Unity Catalog. So now your Unity Catalog can have an exact mirror of what you had inside Lake Formation and vice versa. It's actually an omnidirectional sync that we could do between Databricks, Snowflake, Lake Formation, Glue, HMS, just in general. And I think we have a couple other catalogs, if not now, then in the works. So yeah, it's something that makes that governance a lot easier. Hopefully that helps.
Excellent, dude. Well, I think it is time to kick you off the stage.
All right. Good to
Say
be here.
adios
Thank you.